Good day, students. So welcome to part two of the mixed review, getting you ready for the upcoming exam. In this clip, we're going to be going over some trig identities problems, trig ratios, expressions, and graphs. Okay. So let's start out with question number one. It says find the identical expression for the following: sine t equals 1 minus cosine t. So we remember our Pythagorean identities. We know that sine. We know that sine squared t plus cosine squared t or theta equals 1, right? And that tells me that 1 minus sine squared t is the same thing as cosine t. And if I factor this, I can also write this as 1 plus sine t times 1 minus sine t. Okay, all these three mean the same thing. And also, the square here, 1 plus sine 1 minus cosine squared t, 1 minus cosine squared t is equal to sine squared t. And I can also factor this into 1 plus cosine t times 1 plus minus cosine t. Okay, so just keep these formulas in mind. All right, so let's take a look at this. Sine t over 1 minus cosine t. Now, to find an identical expression, I want to create a perfect square. I want to create a difference of squares in the denominator. Okay, so to do that, I have the difference, so I need the sum. Okay, so because I know if I have 1 plus cosine, 1 minus cosine, I can replace that with sine squared. So to do that, I will introduce 1, the conjugate, to be specific, 1 plus cosine t in the denominator, and 1 plus cosine t in the numerator. All right? So that gives me sine t times 1 plus cosine t. And then if in the denominator, I could just follow it out. But I can use this shortcut right here. 1 plus 1 minus cosine t times 1 plus cosine t. That's the same thing as sine squared t. Okay? Alright, now since I have a square at the bottom, let me keep the numerator the way it is. I'm going to break down the denominator into sine t times sine t. Okay? I can divide this out, and our final result is going to be 1 plus cosine t over sine t. So the identical expression is option B. Okay? Alright, let's take a look at number 2. There's another question on identities. Is this statement true or false? So we have to remember our quotient identities. The tan B is going to be sine b over cosine b, and also a reciprocal identity that secant b is basically 1 over cosine b. Okay, I'm going to use these two to substitute tan and secant. Okay, so let me rewrite the expression. Tan square b minus sine square b divided by secant square b minus 1 is it equal to sine square b. Okay, I'm going to start out by making a substitution. Replace tan with sine over cosine. Okay, so on the left side I'm going to have sine square b over cosine square b minus sine square b, let's write this as a fraction, over 1. This whole thing divided by secant can be replaced with 1 over cosine square b minus 1 over 1. Alright? Now I want to create a LCD in the numerator. To find the LCD, I'm going to times it top and I want the LCD of cosine square 1 is cosine square, so I'll multiply this top and bottom by cosine square b and cosine square b. In the denominator, we have the same scenario. The denominator is, I need an LCD. The LCD of cosine square b and 1 is cosine square b. So I need to change this into cosine square b. So I'll multiply by cosine square b top and bottom. Okay? And that gives us, so the question, we're still trying to see if that is equal to sine square b, right? Alright, so if I do the top, I'm going to have, I'm going to have sine square b minus sine square b cosine square b divided by cosine square b, and this whole thing divided by 1 over, well, we already have the same LCD, so I can express them as a combined fraction. So we have 1 minus cosine square b divided by cosine square b. Okay? If you look at a fraction, the numerator and the denominator, they have the same denominator, right? So I can eliminate those two identical fractions by multiplying the numerator and the denominator by that common fractional term, which is cosine square b. In the numerator, you notice this divide out with this denominator, and the denominator, this also divides out with this one, okay? So we're going to be left with, on the numerator, sine square b minus sine square b cosine square b, divided by, in the denominator, 1 minus cosine square b, okay? Question is it equal to sine square b? That's what we're trying to see, is true or false. Is this equal to sine square b? Okay? Alright, in the numerator here, I can factor out sine square b. Let me factor that out. If I factor out sine square b, I'll be left with 1 minus cosine square b, divided by 1 minus cosine square b equals sine square b. Is it true or false? If you notice, these two divide out. This divide out to 1, and this divide out to 1, and you end up with sine square b equals sine square b. So the statement is true. The original statement is true. Okay? Alright. Let's move on to question number 3. It says find identical expression for the expression cosine squared x plus tan squared x plus 1. So we need to remember the Pythagorean identity that tan square x plus 1 equals secant square x. And we also have to remember that secant x is a reciprocal identity of cosine equals 1 over cosine x. Okay? Alright, so this one is gonna become cosine square x. Tan square x plus 1 will be replaced with secant square x. Isn't this Pythagorean identity involving tan and secant? Now I'm going to express secant using a reciprocal identity. This is going to be cosine square x times secant will become 1 over cosine square x. Okay? You notice these are identical, so they divide out to 1. And final answer is just simply 1. So the answer to number 3 is B. Alright, moving on to question 4. So there's a statement true or false. I'm going to factor the numerator using the difference of squares formula. We know a squared minus b squared. To factor that, you read the first and the last, and you add and subtract the square roots, right? So you got a plus b times a minus b. So let's do that here. I'm going to root the first term and the last term, and plus or minus the square roots, okay? That factors the top. So that's going to leave me with 1 minus sine square theta times 1 plus sine square theta over 1 plus sine square theta. Okay? Is it equal to sine square theta as a question? Now you notice these are identical, so they divide out to 1. So the question is 1 minus sine square theta equal sine square theta? Obviously it's not, right? Remember, 1 minus sine square theta is the same thing as cosine square theta. Is cosine square theta equal to sine square theta? Absolutely not. So this statement is false. The original statement is false. Okay? Alright. Now let's move on to the next question. We have to find the inverse cosine of negative root 3 over 2. So we're just going to start with cosine. We're going to be restricting ourselves to the cosine row. And we're going to be looking for this value and see what angle generates this value. Okay? So let's say that let's restrict our input values. Okay, let's say we're from negative pi all the way to pi. Okay, so from negative pi all the way to pi. So we're just going to be focusing on the first two quadrants. All right, so if we're going from negative pi to pi, we just stop right here. This is our boundary. We're not going to go past this side. Okay, so everything here doesn't really count. I'm just going to focus on the left side. Alright, so let's see. we're on the cosine row, so let's see. Starting from cosine, I'm looking for this value right here. So let's go, that's not it, that's not it, that's not it. Oh, there you go, bam, right there, okay? So our answers, we have two candidates, either the positive or the negative. So it's either going to be positive 150, or it's going to be negative 7 pi over 6 degrees, okay? Negative 7 pi over 6 is negative 315. So let's see which one has the answer for us. The correct answer is either 150 or negative 7 pi over 6, which is negative 315. The answer is option letter D. Okay, so there you have it. Okay, let's take a look at the next question. What is secant of the inverse cosine of 1 over root 2? So this one, we don't need a chart for this one. We can do this by hand. So let's work it out. So remember the identity, secant. Secant theta is what? It's a reciprocal identity of cosine. Secant theta is 1 over cosine theta. So this expression, secant of the inverse cosine of 1 over root 2 can be written as 1 over cosine of the inverse cosine of 1 over root 2. Since cosine and inverse cosine are inverses, they cancel each other out. So you're left with 1 over 1 over root 2. Okay? So we're going to drop change flip. Since we have a fraction in the denominator, we drop the top, which is 1, and multiply by the reciprocal of the denominator. If I reciprocate this, the denominator goes to the top, numerator comes to the bottom. So we have we have root 2 over 1. Multiply out, final answer is square root of 2, option letter A. Alright, moving right along, question 7. It says graph y equals 4 cosine x plus pi over 3. Okay, let's write this in transformational form so we can find the new origin and amplitude. So we can write this as y minus 0 equals 4 cosine 1 times x plus pi over 3. Okay, so looking at this, we know that the new origin is going to be negative pi over 3 for the x coordinate, because you do the opposite of the number next to the x, and 0 for the y. So we're going to have a phase shift, okay? So the phase shift in this scenario is negative pi over 3. Or pi over 3 units to the left, okay? Vertical shift is none because the y coordinate is 0. No shifts up or down. Our period is 2 pi over b. In this case, b is 1, right? This is the value of b right here. This is b and that's a. So b is 1, so it's going to be 2 pi over 1, which is just 2 pi. Okay? And let's not forget our amplitude. Our amplitude is going to have a value of a, which is, actually the absolute value of a, which is just 4. Alright, so since we're dealing with a cosine, remember the orientation of a cosine is like a cup, right? One period of a cosine is like a cup. So let's see. Considering the fact that we have a phase shift of negative pi over 3, our new origin will be centered at negative pi over 3 and 0. So let's graph that on our alternatives. Negative pi over 3, this is negative pi, this is negative pi over 2, this is negative pi over, let's see. Alright, so negative pi over 3 is somewhere here. It's kind of hard to see because of the calibration. Negative pi over 3 is going to be right here, right here, right here, very close to pi over 2 right here, and right here, okay? So let's draw in our new y coordinates. So this is the first new y coordinate. This is the new y coordinate, the second one. Your new y coordinate, and this is your new y coordinate, okay? So we're looking for a cup starting from that new y value that we have. So remember, this is the orientation of your cosine, something like this. You have a cup. So let's see. This is an S, and it's going downwards. from the new origin, so we know that this is going to be a negative sign. This is an S going upwards from the new origin, so we know that this is going to be a positive sign. This is a cup, but it's upside down, so it's a negative cosine. This is a cup facing up, so it's a positive cosine. So since we have a positive cosine here, because A is positive, the answer is going to be option D. Okay? Alright. Okay, for question 8, we're going to make up a problem involving, this is going to be a trig ratios question. Find the value of x. Okay, find the value of x. So in this case, what we have is we have a right triangle. Let me go ahead and sketch that for you real quick. We have a right triangle with the following configuration. Just adjust it a little bit. This right here, this is x degrees. This is 12, and this is 14. Okay, so I want to find what x is. This is a right triangle. Alright, so this is a trig ratio problem. So the question is, what trig ratio are we going to use to find the value of x? There are 3 trig ratios we can use for right triangle trig, which is SO, TOA, sine, cosine, and tangent. Alright, so which one are we going to use here? Is it sine, cosine, or tangent? Since this is the reference angle, not the 90-degree angle, since that's the reference angle, that tells me that the side that's opposite that angle is your opposite. Okay, so this side is the O for opposite. This side right here is the adjacent. And the side opposite the 90 degrees, always the longest side, is your hypotenuse. Okay? In this problem, I don't know the hypotenuse, I don't need it, so let's scratch it. It doesn't count. We're looking at O and A. Which trig ratio has O and A in it? It's tan, right? So we're going to set up the ratio tan. Tan of the angle, the reference angle, under consideration, tan x equals opposite, which is 12, over adjacent, OA, right? That's what OA means, opposite over adjacent. Now to get x by itself, we use the inverse of tangent. Okay, we take the inverse tangent and multiply. We take the inverse tangent of both sides, take the inverse tangent of the left side, tan x, and you take the inverse tangent of the right side. Okay, so let's see what happens here. These two are inverses, so they cancel each other out. So we're going to have x equals the inverse tangent. We can reduce this, but it doesn't make any difference. We're just going to plug it into the calculator anyway. So let's conserve our energy. So let's put this in a calculator and see what we get as our result. So remember, we're working with degrees here, so we have to make sure that our calculator is set into the right angular measure mode. So you just press mode and make sure degrees highlighted. And we'll do the computation. So the inverse tan of 12 divided by 14, or 6 over 7, is 40.6. So x is basically 40.6 degrees. 40.6 degrees. Okay, so there you have it. So thanks so much for taking the time to watch this video. If you feel free to subscribe to my channel by clicking up here if you haven't already done so. More videos can be found on mathserve.com. Thanks again and have a wonderful day.